question, which is all about two objects, a small mass and a large mass, small m and big M, and their motion. Have a look, and when you're ready to see an explanation of the answer, hit play. Okay, so this is a nice one because it really does test our understanding of physics and some of the stuff we experience in our everyday lives. Okay, you should be aware that if you have something on top of another object, that they will move together. However, if you push the bottom one fast enough, then the top one may slip off, and that's exactly what this question is looking at. Now, the key to understanding this is thinking about the forces between the objects. Now, we're looking at the top mass here. The top mass will move forward, and the question is why? If it's moving forward, if it's accelerating forward, then there must be a force acting on the small mass in that direction. Now that force is the friction between the two objects. There's nothing else pushing it, nothing else pulling it. And so actually, as the large mass moves forward, it pulls the small mass forward via the action of the friction force between the two surfaces. Okay, so in this case, we can start to kind of understand things. Now, just to be clear, I'm using small letters here for the top mass. So the net force on the small mass is small f, is equal to the friction force acting between them, and that is equal to the small mass times its acceleration. Now, the bit that I find that students really struggle with is the fact that if these guys are moving together, then that means they have the same acceleration. If they didn't have the same acceleration, then they would move relative to one another. So here, I'm saying that small a, the acceleration of the small mass, is equal to the acceleration of the large mass. They must be the same in order to stop any relative motion. From here, we can start to do some force analysis. Okay, we have friction on a horizontal surface between those two. The friction is mu times the reaction force. The reaction force is the weight, and therefore we can put those together to say that the friction force between the surfaces is mu times m, small m, g. If we then substitute that into that top equation, we can see that mu mg is equal to the mass times the acceleration. And remembering both accelerations are the same, I can substitute large a for small a here. And we notice that our masses cancel, and that's really key here. We can cancel out the masses, and we're left simply that the acceleration of both the bodies, and hence the acceleration of a, is simply equal to mu times g. And that's our answer here.